Now here is the problem number 2. We need to find the power lost internally by the battery in the circuit below. So here is the circuit. Okay, P lost, the lost power, is given by the current in the circuit squared times the internal resistance. This is the internal resistance. So other equations, by the way, for the power, just to remind you, are the following. So it's I times delta V in general, but when we apply it to the load with a given resistance, it's also I squared times R, or delta V squared divided by R. Okay, so we are going to use this equation over here this time, as it is most convenient. So obviously we know the resistance here is given, right? But obviously we don't know is the current. So we need to find the current first. To find the current in this circuit, what we need to do, we need to find the equivalent resistance of these two guys, which are connected now here in series. And once we found the equivalent resistance, since we know the voltage, we'll be able to find the current using the Ohm's law, right? So the equivalent resistance, they're connected in series, the resistors is just the sum of R internal plus R, so it's 0.5 ohms plus 2 ohms, it will be 2.5 ohms. So now we can use the Ohm's law, which connects the current and the potential difference and the equivalent resistance. So we'll substitute what we know into this equation, find the current. It is 20 divided by 2.5 amperes at the end of the day, so we'll get 8. Okay, so now we can use this and substitute into the equation for the power. We know R, we found I, so we just substitute and we'll find the lost power. And so I did that and I found 32 watts. So key equations here were the lost power, or just the power, which is defined by this set of equations, and you should choose the one which is the most convenient for a problem at hand. So in this case it was this one, or that one. Next, the equivalent resistance of the resistors connected in parallel is given by the sum, and finally the Ohm's law. Okay, these are the concepts which we apply to solve this problem.